Microlution Inc, which reports more than 100 micromilling and laser machining platforms installed worldwide. Growth is a constant. Founded in 2005 by Chief Executive Officer Andy Phillip and Chief Technology Officer Andrew Honegger, Microlution has grown every year since its inception, even through the recent recession, according to Anik Bhattacharya, the company's Vice President in charge of sales and marketing. From its original 1,200 square foot facility near Chicago's United Center Stadium to its new 20,000 square foot location on the city's northwest side, Microlution has sustained its growth by remaining evenly diversified among the markets it serves, including medical, automotive, consumer electronics, and the semiconductor industry. An equal measure of the credit for the company's growth, according to Bhattacharya, is owed to Microlution's willingness to enter new markets deemed to be a good fit, which is why the company will soon add a microlathe to its micromachining product portfolio. Given the company's growth and imminent launch of its new microlathe, Micromanufacturing magazine dropped by the company's new location at 6635 West Irving Park Road for a tour and a little insight into the company's success.
We've been growing quite a bit over the last few years. The growth was really spurred by a number of different markets and applications that we got involved in, and we were just busting out of the seams at our old place. It's been an interesting ride. I mean, when we started the company, we were in a 1,200 square foot facility down by the United Center. We then moved to a 4,000 square foot facility. Then we moved to a 12,000 square foot facility. And 4 months ago, we moved here into a 20,000 square foot facility. One item I'd like to kind of point out as we walk towards the back is you can see here we have some pictures that kind of remind us of the progression of our product line. When we first started the company back in 2005, this was the first product here that we brought to market, the 310S. Small, 3-axis, high-precision milling machine. Again, the focus of our company has always been building high-precision manufacturing solutions that are optimized for small, high-precision parts. This was our first product. This product quickly evolved into a product that we still sell today, which is the Microlution 363S. Small footprint, high-precision, 3-axis micro machining center. Our growth has really been driven by being able to provide integrated manufacturing solutions to our customers. And so not only delivering, let's say, a 363 for somebody to make parts off of, but delivering a 363 that is geared for a particular type of application where we do a lot of semi-customization on. We think of our product line as core products that we then build off of that really address a customer's challenges in terms of fabricating extremely tough, high-precision, small parts. When this product we were selling starting in 2006 and it was gaining great traction, a lot of people mentioned that, what about handling slightly bigger parts? What about 4th and 5th axis? That led us to release the Microlution 5100S in 2009, a product that is still on the market today and still generating great sales for us. From the beginning of the company till about 2009-2010 timeframe, our focus was on mechanical machining operations. In 2010, we broke into the laser world, primarily driven by applications in the automotive industry and medical industry for micro-hole drilling. The product offering that we came out with in 2010-2011 timeframe is the ML5 product. The ML5 is an ultra-fast 5-axis laser workstation that is optimized for micro-hole drilling. This machine has seen great success for us, and it's been one of the prime reasons for our growth, especially in the automotive and medical industries for applications where holding extremely tight accuracies on extremely small holes is very, very critical. Another product for us here is the Microlution FLP, which is our fast laser platform, where the ML5 was geared for micro-hole fabrication. The FLP product is geared towards extremely high accuracy cutting of flat materials, okay, as opposed to drilling small holes. And the microlathe is our newest product focusing on micro-turning applications for extremely small parts. And the microlathe is a product that we're very, very excited about. And there are some key killer applications for that machine that was the reason behind which we developed that system. Our manufacturing space is broken into two halves. One half is focused on product development and application development. The other half is focused on where the machines are actually built. we build all of our own equipment here. So the half that you're seeing here is the half that we focus on product development and application development. As we develop new features, develop new products, they need to be tested. The first machine here is the 5100S, which is our 5-axis machining center. Obviously, whenever we're engaged in conversations with customers, people like to see parts cut, sample parts cut. This is one of the machines we use to do that. So right now it's actually running a job for an application that we're working on. It's cutting not really an impeller, but an impeller-like feature there. For the purposes of video, we had cut this earlier and now we're running it without coolant, but this would be an application that you would be running with coolant. Down below, automatic tool changer, you have your laser tool sensor, all the bells and whistles you would want to be able to make small, high-precision parts effectively. You know, one of the keys for the way that we've been able to grow the company is that we're not only the machine tool builder, we don't just deliver the machines. We work with our customers very, very closely to truly deliver solutions to our customers. You know, when we're talking about integrated manufacturing solutions, you're talking about not only the system that you use to fabricate the part, but how do you characterize incoming material in high volume settings? How do you load the material into the machine? How do you measure the part? How do you characterize the part? How do you machine it? How do you characterize the outgoing part? So a lot of what we do as a company and the way that we've been able to grow the company has really been focused around developing these integrated processes for our customers and working very closely with our customers to understand what they need and delivering a full soup to nuts type solution for people. So this product here is our new lathe. It's not fully built. You know, obviously on this machine, when it's completely built, it has full sheet metal enclosure, things of that nature, but this is a test bed for us for this new lathe. This lathe is a 4-axis lathe, okay? It's a hybrid base, so you have a polymer cast concrete base upon which we mount a precision ground granite block up here where the machine is built from. So it's a hybrid base, polymer concrete cast base with a precision granite top that the machine is built off of. It's a 4-axis lathe, so you have your spindle here that moves in this direction. Also, the spindle has the rotary axis here, so that's 2 axes. You have a gang tool type setup here where this moves in this direction, and then also you have a 4th axis of motion here. And you can mount your live tools there for high-speed milling operations. So one of the aspects when you're dealing with small parts is obviously they're very, very small, very tough to handle, very tough to see what you're doing. One of the nice ease of use features, I think, that we've integrated on this machine is a nice clean camera integration that allows the operator to visually see what's being done. And this output, if you kind of pan over to the HMI on the machine, you can see the output right here. So look how small that piece of bar is, and the operator can see much clearly up here what's going on. Okay. Right now it's going to be pulling the bar out to the proper length. Initial facing operation. It really gives the user of these machines some comfort to be able to really see what's going on with such small parts, small tools, making sure the tools are aligned properly. This camera is a nice feature. Along this track here is where we focus on building our larger systems. So if we walk this way, I'll kind of walk you through what's shown here. This is one of our 5100s that's currently in build here. As we kind of walk down here, now we start getting into our laser machine chassis. There's a couple key characteristics that we focus on. All of our machines across the board are built off of precision ground granite bases. Granite provides excellent thermal stability, excellent inertial stability. All of our machines across the board, whether they be mechanical machines, milling machines, turning machines, laser machines, we're using glass scale encoders from Heidenhain. Machines hold ±1 micron, substantial sub-micron repeatability. The ML5 has been an extremely successful product for us, not only in the automotive industry, but also in the medical industry. Again, this product is focused on micro hole fabrication using ultra-fast laser technology. This is a 5-axis machine, so we have this entire assembly moves this direction, moves left and right. You have a tilt stage here that swings as such, and you have a full rotary stage on top. That's 4 axes. Your 5th axis is underneath this device, which I'll come to in a second, but your 5th axis is here, which this moves in the vertical direction. This is the scan head. The scan head delivers the laser beam to the part. The scan head is pretty unique in the sense that it is able to take the laser beam, position it in 3 axes of motion, X, Y, and Z, as well as it's able to spin the laser beam like a drill and then process the laser beam as such. The important aspect of that is that we're able to have a lot of flexibility over the shapes of the holes that we're looking to make. Positive taper holes, negative taper holes, straight taper, no taper holes. Making a variety of different shapes is possible with this system, which is one of the reasons that people are very excited about this machine. You're able to use it not just to make straight taper holes, but you have a lot of flexibility over your shape. The fact that we're integrating a femtosecond laser, the quality of the edges is extremely good, coupled with the fact that the machines that we're building are extremely accurate. This is one of the areas where in the laser world, typically people have been integrating lasers into off-the-shelf systems, buying off-the-shelf stages and putting these stages together. At Microlution, again, one of our main focuses is machine tool design. And so we design our machines from scratch, from the bottom up, to really be optimized for particular applications. And so that's where we're seeing our performance advantages out there in the laser world.